elements. Just going to calculate some here. Okay, so I'm going to go through the first one on how we'd go solve it, because it might be a bit of a while since we've done it, and then I'm going to let you answer a few more, and we're going to poll it, and we're going to see what everyone thinks. All right, so chromium, Cr there, and it's asking us for the oxidation number of that in Cr2O7 2-. So how we go about that? Oxidation number of chromate or chromine, it's going to be X, unknown. So we use the rules for what we know to help us work out what we don't know. So we know oxygen is always, right, -2, and we know that from rule 2 or 3 in the where was it? Rule something, rule 5. Okay, unless it's in hydroxide. Unless it's in a peroxide or OF2, but it's not, so oxygen's -2. So what I like to do is you do the oxidation number down the bottom, -2, and then at the top of the number, you put the sum of it. So there's 2 is the negative charge, right, on oxygen there. There's 7 of them, so it's going to be -14 as the total sum. Yep, that's right. What's in the chat by Savio there. Okay, so oxygen is -14 as its overall charge or contribution in this particular compound. And so now we've got X -14 equals -2, because you can see the charge on the chromate ion is -2. So you go and solve for X. How do you do that? How do you go and solve for X in this case? Yeah, so I put a 2 in front because there's 2 chromate ions. It's 2X -14 equals -2. So then you take away and you put 2X equals, and so you're adding 14. Cancel that out, adding 14. What does that give you? +12. And then you do X equals +6. So each chromine atom has a +6 charge. So down the bottom, the individual contribution of each chromate is +6. Okay, so this is the individual oxidation number down the bottom. So I think that's helpful to write the individual down the bottom and then the total up the top. Or you can do it the other way around. Just because when you get more complex compounds, it's more difficult. All right. So I would like us, please, to do MnO, Mn atoms in MnO4. Just going to check the questions. Dio2. Thanks, Antonio. You can put your comments in the chat if it's easier, because as a question, I don't see it as often. Yeah, there we go. Thanks, Antonio. All right. So let's go polls and let's go. Where are we? Where are we? Question 1C. Okay. I would like you to type in the answer to the charge on the ion. Okay. Remember to try and put a plus in there, because you need to tell me if it's positive or negative. Giving you a bit of a hint. Looking pretty good. 20 people, 34 people. Nice. Good one, good one, good one. All right, so MnO4, we do the same thing. Oxygen equals -2. There are 4 of them, so -2 times 4 equals -8 is the overall charge on oxygen. Okay, so the individual contribution down the bottom, the total contribution up the top to the oxidation number. It sums to -1. So we have got X -8 equals -1, because the charge there is a -1 overall. And so now you need to put this to the other side. So X equals what? As many of you said, +7. So we just move 8 to the other side, makes +7. All right. Last one I'd like to do, please. Where did it go? Here we go. I've made this a multiple choice. Okay. So Cl atoms in OCl-, hypochlorite. This is one of the ingredients of bleach. So household bleach. This is actually what's in the bleach there. OCl in some cases. So what is the oxidation number of chlorine in this instance? Looking good so far. So you got to go back to the rules in this one. Okay. So overall, so it's x plus x equals -1, or x plus y would be more sensible, wouldn't it? Okay. So x plus y equals -1. We know oxygen is -2. How do we know that? Because it's in the rules. Chlorine, well, it probably would be -1, wouldn't it? Because it's in the 17th group and it gains 1 electron. But if you look at the rules, and the rules say the more electronegative element is the one that maintains or has the negative charge. So if you go back up to those rules, give me 1 sec to get the mouse, go up to the rules here and you see oxygen here is greater than chlorine, therefore oxygen is the element that's going to be the negative charge or contain the negative charge. So oxygen will be -2 and chlorine there will actually be +1 because the overall sum is -2 plus x equals -1. We've got -2 plus x equals -1. You plus 2 the other side, so x equals +1. All right, that's enough oxidation numbers. One more. Do we have it? Yeah, this one, F. All right, it's a bit harder, this one. How would you do the oxidation half? I'll tell you right. Yeah. So it's a good question in the questions there. When you have metals which are metalloids, or when you have transition metals, they can have multiple states. So you'd have to have more information there, but it probably would be +4 for the example that you've given there, Pramod. But there'd be a bit more information given to have to be given to you. All right. So we're going to do this one here. When you have ionic compounds, this is the key here, just getting the question. When you have ionic compounds, you need to separate those into their individual compounds. Okay, so don't think of it as NH4, NO3. Think of it as an NH4, what does that equal? And what does an NO3 equal as a charge? So think of it as this is one particular thing, and this is the other particular component we're trying to work out. With those, you then work out the charge on each of those. Right? I'm not going to tell you because you should know the charge on those. If you don't know the charge on those, then you need to learn that. It's going to come up a lot in chemistry. A lot. All right, so does anyone remember or know what this is called? Like either of them? Type it in the chat for me, please. What are we calling these? Nitrate? Almost nitrate. Yep. Oh, yep. Sorry. Yep. Whoops. Not almost. Definitely is nitrate. Nitrate ions. Come on, pen. All right. So that's a nitrate ion, and it's an NO3 1-, and this is ammonium. Not ammonia. Ammonium. It's a +1. So if you know that, you can work out you've got hydrogen as a +1. Okay. So I'm going to take out this here now. +1, overall contribution is +4. Therefore, ammonia, there's a nitrogen, one of them, and it sums to a +1 is going to be a -3. Okay, because there's a +1 there. So we've got 1 times +1 times 4 equals +4 for hydrogen. So then nitrogen -3 because it sums overall to the -1 charge. And then nitrate over here, we've got oxygen. So O equals -2 times 3, which equals -6. And therefore, nitrogen is going to equal -6 plus X equals -1. What's that going to be? +5, isn't it? All right, so +5 and -3. So we should be able to do those.